We are taking an example of CDMA or code division multiple access. C is for chip pattern. Chip pattern means the unique code assigned to an individual station. Every station is assigned a unique chip sequence called as chip pattern. Two machines will not have same chip sequence. Wherever you see D, that will be data bits. So there are properties related with this chip pattern. Before that, when you are going to send 0, we will use -1. When we will send 1, we will use +1. For example, there is a code. This code we have used 4 only for simplicity. It can be 4, 16, 64. It can go above. So -1, 1, 1, -1 we have taken. So this is a chip pattern or chip sequence. When we are sending 1, we will send this. If you are sending 0, then the same machine will complement it. That is, it will make it as +1, -1, -1 and +1. So complement will be sent. Okay. Now we are ready for the actual example. Let us assume we have 4 stations. Station 1, station 2, station number 3 and station number 4. As I said, every station will be assigned a code, and depending upon the code, they will send the data. They send the data on a single channel. That is why we are calling it as code division multiple access. So let us take the example. We are again taking only 4 of these. It can go beyond 64, 20, 128. So say C1 is 1, 1, 1, 1. C2 is 1, -1, 1, -1. C3 is 1, 1, -1, -1. And C4, 1, -1, -1, 1. These are the chip pattern or the unique chip sequence of 4 machines or 4 stations. So what are the properties? The first property is that if any pair you take and you take the inner dot product, then you need to get a 0. That is, you just have to take the dot product of the pair. Okay, I'll give an example. Let us take C1 and C4. Now C1 is 1, 1, 1, 1 and C4 is 1, -1, -1, 1. We are taking the code assigned to C1, C4, that is station 1 and station 4. Now what do you multiply this 1 with 1? What do you get? 1. Now multiply the second one. That is 1 into -1 is -1. Third one, 1 with -1 is -1. Fourth one, 1 with 1 is 1. Now you add them. When you add, you will get a 0. You take any pair of these code sequence and you take an inner dot product. It should show the orthogonality pairwise. The second important thing is if you multiply the code of a station with itself, it should get, or you should get, the number of stations. What does it mean? Let us take now C3. Now let us take the dot product of C3 and C3, inner dot product. So we have C3, the code is 1, 1, -1, -1. Then we have again same thing, 1, 1, -1, -1. Now take 1 into 1 is 1. 1 into 1 is again 1. -1 into -1 is 1. -1 into -1 is -1. Just add them. What do you get? 4. How many stations are there? 4. So now both the conditions are fulfilled. You can only give code when they fulfill this condition. Right? The necessary and sufficient condition is done. Now we have to send the data. Let us say station 1 is sending data as -1. As I said, D will represent data with bits. D2 is sending +1. D3 is sending -1 and D4 is sending 1. Now how do we send it? So when the state, because all of them are going to send together, so we have to multiply C1 with D1. So C1, the data has to be multiplied with the code, then only it will come to the channel. That is, we will multiply -1 with C1. So multiply -1 with every element, 4 element we have. Then we will multiply C2, D2, same thing, C3, D3 and C4, D4. And then we are going to add it. And the resultant will go to the channel, to the transmission medium. So let me just do it. C1, D1. What is C1? 1, 1, 1, 1. What is D1? -1. So all will be negative. So it will be -1. I'm multiplying each code with -1. So -1. Now C2, D2. Now 1 into 1 is 1, -1 into 1 is, so same thing will come because multiplying with 1. Same thing will come. Now C3, D3. Now we are multiplying the C3 with -1. So all will be inverted. You will get -1, -1, 1 and 1. Now same thing with C4, D4. Now we are multiplying 1 with the code. So same thing will come. 1, -1, -1 and 1. Okay. Now we are done with this. Now you have to add it. So now add pairwise or 4 quad wise. You add this -1, 1, -1, 1, 0. Now -1 4 times you get -4. Again -1, 1, 1 and -1, it will be 0. Then fourth one, 1, -1, -1, 1 and 1. Again you will get a 0. So this is the final content that is going to go in the channel. 0, -4, 0 and 0. Okay. So this is going to go. Okay. Now the sending is done. What about retrieval? The retrieval, the receiver has to have the code already known to itself in advance. Okay, we will multiply the code with the channel data and will divide it with the number of station. You will get the bit what is being sent. Let us start. 0, -4, 0, 0 was there. Now let us say the receiver 1 wants what the station 1 has sent. So this receiver wants to know what the station 1 has sent. What is in this code? So what we'll do? We will take the channel data 0, -4, 0, 0. And since the receiver already know the code of station 1, which is 1, 1, 1, 1, we have to take the inner product, dot product. What it will be? See, 1 by 1. 0 into 1, 0, -4 into 1, -4, 0 into 1, again 0, 0 into 1, 0. Now you have to add them, just add them. What do you get? -4. Now what you have to do? You have to divide it by the number of stations. There are 4. So divide by 4. What do you get? You get a -1. And this -1 was sent by the station 1. Okay. This you have to do for every station. This is how the code division multiple access work. This is an easy scenario, but in practice, it goes for a long code. Thank you so much.